Hey there and welcome back. Today we're going to be comparing exponential expressions. We're also going to be proving that exponential expressions are equivalent to each other using all of those wonderful 7 different rules that we learned in the previous couple days. We've been practicing the product of powers, product of powers, quotient of powers, power of a quotient, zero exponent, and negative exponent property. We had been practicing using all of those different rules, and we're memorizing the quick tricks so we don't have to keep expanding the exponential properties. Well, now we're going to be trying to just create equivalent expressions for different exponential expressions that we are originally given. Write 4 expressions equivalent to 2 to the 13th power and explain your reasoning for each expression. So you can get creative with this. All we're doing is creating equivalent expressions, meaning they mean the same thing. So what I want you guys to think about is trying to use the properties that we've learned to maybe unsimplify this expression into 2 terms that you would combine together by using those properties. So first, let's talk about maybe the first one that we learned, which is the product of powers. Get a pen out. There we go. Okay, so product of powers. Now, the product of powers said that if you had 2 of the same base multiplying together, so here we have base 2, so we'd have 2 times 2, but we have to put exponents on those 2's. Now, when we multiply 2 of the same bases together, you're supposed to add the exponents. So I can actually come up with many equivalent expressions just by coming up with 2 numbers that add to 13, like 10 and 3. Because 2 to the 10th power times 2 to the 3rd power will equal 2 to the 13th power. I can come up with another one, 2 times 2, but we can make the exponents 2 different numbers that would add to 2 to the 13th power. Maybe like 5 and 8. Okay, 2 to the 5th times 2 to the 8th, that would also become 2 to the 13th. So I can keep going. I can generate many equivalent expressions that would generate 2 to the 13th power. Okay, but we don't just have to use the product of powers. We can use the quotient of powers. Which said when we divide the 2 bases, so 2 over 2, we would subtract the exponents. So if maybe we did something like 2 to the 4th, we'll do 2 to the 16th over 2 to the 3rd, because 16 minus 3 is 13, which would generate 2 to the 13th power. So that is another equivalent expression. And I can keep going, just making those division problems where the exponents subtract to equal 13, like 2 to the 20th over 2 to the 7th, because 20 minus 7 would be 13. Okay, so that's another equivalent expression that would get me 2 to the 13th power. Okay, now we don't just have to use the product of powers or the quotient of powers. We could use the negative exponent property. Okay, which says that in order to make an exponent the opposite sign, you just need to take the reciprocal. So another equivalent expression to 2 to the 13th power, if 2 to the 13th can be written over 1, if we flip it and make the exponent negative, we would get 1 over 2 to the negative 13. That would also simplify to 2 to the 13th power. So all of these that I've written so far, that I've boxed, are equivalent expressions. They may look less simple than the original, but they are equivalent. Okay, I'm going to give one last example of this because I've been explaining my reasoning the entire way through. Let's use another one of the exponential properties. Let's see, how about, I'm trying to think. If we use power of powers, we'd have to multiply to 2 to the 13th. So we could write, if we use power of powers, We could do 2 to the first power raised to the 13th power. That would definitely be an equivalent to 2 to the 13th power. We could also combine numerous, sorry, I'm going to put this in a box because that was the equivalent. We could also combine numerous different exponential properties, like if we wanted to do the product of powers, 2 to the, let's do 6th power times 2 to the 7th, which would give us 2 to the 13th. And then we could put that over 2 to the 0th power. Okay, the 0 exponent means that it would become 1. So that is, even though it's not simple at all, it's got a lot of base of 2's, that would actually simplify to 2 to the 13th power. So there are many, 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 many equivalent expressions for just one exponential expression. And you should be able to use the exponential properties in order to generate as many of these equivalent expressions as you'd like. So in this first U-try, what I'd like you to do is look at the 4 options and try to simplify them to see if any of these are actually equivalent to 5 to the 8th power. Go ahead and give this a try. All right, I've got one last example for you. It says choose one of the 3 symbols to compare the following expressions. So we're choosing from one of these 3, the greater than, the equal to, or the less than symbol. So what you need to keep in mind is both the left and the right side may be able to be simplified in order to show that they are either greater than, less than, or equal to. Just keep in mind that if you want to have the same base, okay, so actually I'm going to write out these tips for comparing. You want to have the same base. You want to have them in whole number form, because if it's in a fraction, it might get a little confusing on the brain, and I'll explain why in just a minute. So try to change them into whole numbers, even if that means you need to make the exponent negative. And then you're basically going to just choose the highest exponent. Okay, because whichever statement has the largest exponent is the larger of the 2 expressions, as long as they have the same base and they are in whole number form. Okay, so let's do the first one. The left side is already pretty simplified, 3 to the 6th power. Okay, but we can actually make the right side simpler for these 2 bases to combine together into just one base of 3. And when we multiply 2 of the same base, we're supposed to add the exponent. So 2 plus 3 is 5. So they have the same base of 3, but one has an exponent of 6 and one has an exponent of 5. Whichever one has the larger exponent is the larger number. So this is a greater than. 3 to the 6th power is greater than 3 to the 5th power. Okay, let's do the same thing for part B. Okay, so we're going to use our quotient rule this time on the right side. The left side is already as simple as it's going to get, and it's in whole number form. So the quotient power says if you have 2 of the same base, which here we have 7, combine them together into the same base, so 7 to the, we subtract the exponents now. 8 minus 4 is 4. So now we're comparing 7 to the 4th to 7 to the 4th. Well, those are the exact same thing, so they are equal. So now in our last example, it gets a little tougher because we're dealing with fractions. Now, the thing here is the larger the denominator, the smaller the number actually is because you're splitting it more times. So I think the easiest way to go about this is to make sure that both numbers are in whole number form. So what I mean by this is, let's use our negative exponent property. Okay, so if we use on the left side, if we use the negative exponent property, we can reciprocate, we can flip the top and the bottom of this fraction, making it 4 over 1, or just 4. And instead of raising it to the 16th power, we just have to make that 16th power negative. So this is 4, and I'll write parentheses around that so it's not confusing, 4 to the negative 16th power. That's our negative exponent rule. It says make the reciprocal for anything that has a negative exponent. And you can use this in the opposite way. So in the previous lesson, we made all negative exponents into positive ones by flipping things. Well, you can still use that strategically and make the exponent negative in order to reciprocate the number. So I'm going to do the same thing over on the right side as well. However, the first thing I'm going to do is I'm going to use my product of powers. I'm going to combine these two together just into one base. So I have 1/4 to the, I want to add the two exponents. So 8 plus 2 is to the 10th power. And now again, I'm going to do the same thing that I did over here on the left side. And I'm going to say that this is equal to, if I reciprocate to 4/1 now, or just write 4, instead of to the positive 10, it would be to the negative 10. So now what I'm comparing is a base of 4, and I'm comparing a negative 16 to a negative 10. When we deal with negative numbers, the bigger the negative number, the smaller the number actually is. So 4 to the negative 16 is actually less than 4 to the negative 10. Okay, now I would highly recommend doing this anytime you see a fraction is just go ahead and make the exponent sign opposite and flipping that number so that you can still kind of compare which number in the exponent is larger, not having to think about fractions or anything like that. So we're just comparing, and when we say compare, you're trying to tell which one's bigger or if they're equal. So let's have you guys give this a try in your second U try. Go ahead and simplify the right side, see if you can tell which of these is bigger or if they are equal. All right, I've got a couple of last close and check questions for you I'd like you to try to complete on your own. Please make sure you ask any questions if you have them. And if you're having trouble with any of these, make sure you pause the video, raise your hand, and get the help that you need. Alrighty, so again, we practice applying the properties of integer exponents to, really, we focused on generating those equivalent expressions today by using those 7 exponential properties that we've been studying. The product of powers, the power of powers, power of a product, quotient of powers, power of a quotient, zero and negative exponent properties. And please, if you are confused about any of these properties, please make sure you ask any questions you may have, go back to any sections that you may need help on, and you can go ahead and start your Google form if you think you're ready to move on. Thanks very much. Have a great day.